Greetings, YouTube. So I've been working on a game, a horror game, as my personal project, and in that process, I've been working on a bunch of manager scripts because obviously, with every game, I think you almost need some sort of manager script, and I think I've gotten to like a system that I'm pretty happy with, and so I wanted to kind of share it out and talk about how I structure it, but then also talk about some more basic versions that if you're starting out or you're just needing something to work out how to use a manager. I'll show some of those too at the beginning, and then kind of go into my maybe a little bit more advanced version, but I think it's really flexible and really useful in that way. Now, before I actually go though into coding and talking about managers and stuff like that, I just want to briefly cover like what a manager is meant to do in code. And I think the general idea is that oftentimes you'll have a bunch of small separated classes, right? And these guys all need to know some central knowledge. So say it's a type of item, or they need to be able to say that an event has happened, or you need to know just kind of like what the level settings are of your current level, right? So maybe there's an enemy manager, and these are all different enemies, and they need to talk to the enemy manager to know, hey, should we be more or less aggressive in this particular level, type of thing. So those are the kind of things that are really useful for manager to make a manager class in, right? So we'd make a big old little manager class here, big M, and then all of these guys can know about the manager. And typically what we'll do is there's two ways of kind of structuring them. There's one way where the manager knows about all the smaller bits. So the manager would probably be spawning out each of these kind of independent classes and then can tell them about itself. But then there's the other way where this manager is what we call maybe like a singleton or some other way of finding it that's static. And then when these guys need that information from the manager, they can just go look it up in code by going, my manager.instance, and then they'll have a reference to that manager. In general, anyways, that's kind of like the reasons why we have managers is that we need to have a central class that has a certain amount of knowledge that's centralized and common across all items that might need it. If you're looking into situations where only half the items need a certain thing and the other ones need other things, then maybe you're looking into more like a data object that might be shared across a couple of them, not necessarily a manager class. And later on in this process, I'll go over a couple of my managers that I'm using in my game. But for now, that's just kind of the basic idea of a manager. You're going to need these pretty quickly. You can get wary with some very, very basic games without a manager class, but eventually you are going to need something that acts as a manager. All right, so jumping into code, I'm looking now at what we call a singleton kind of manager. Now, there's many types of singletons you can kind of create, and I'm going to go across another one in a moment. But the beauty of these guys is that they have, across all singletons, always the thing that's going to be universal is that there's only ever going to be one of these managers. And there's various ways of enforcing that mechanism. But the main thing that's important about knowing about a singleton is that they're only going to ever have one. The downside to this is that most singletons, at least, you can design around this to a degree, is that you have to have one. Otherwise, certain expectations break. But we can get into that a little bit later. Just to go across this kind of code, and I want to stress that this is actually perfectly great for starting off, for doing small projects, for doing a little game jam where you just need a little manager that's a mono behavior on a game object. You could easily take this code right here, write it down, change out the singleton for whatever manager name you want, and Bob's your uncle. You're doing manager stuff. And so just to kind of cover a lot of this stuff, just to kind of, in case you're very new to all these things, let's just kind of go through this a little bit line by line. So Singleton Instance, this is just a static variable. So this means, again, that you can access this variable anywhere, which is nice. For example, if I go to this test script, right, I can go and type in Singleton, right, the class name dot instance, and now I have an actual reference to this manager that's managing stuff, right? And if I were to add a function call, or yeah, just let's put a little public void my function, right? Just a normal little function that you would do something in. I'm not going to write much here, but do something, you know. Then in your test script, you could actually go and then call my function, right? So anything that's on this instance is now accessible because it's static. Static can get obviously a lot more complicated than that, but the basic concept again is that you can just access this anywhere. You don't have to, you know, do a get component call or find objects or anything like that. You just look it up. I do have, this is a property, and I do always set them as get in a private set. It's very important for the singleton design that the set is private, which means you can't have another random situation, another class just set this instance to something else, because that would kind of break the design of the singleton. There's only ever going to be one, and it shouldn't really be changing. Now in the awake function, again, awake is just the Unity start function basically, or there's another different start, but it happens earlier than start. And in these type of things, we'll check first if instance does not equal null. This means if there is an instance already, so say you can take this game object with the script on it, you can throw it into every single scene you made. And the first time you load any scene, it'll take that instance, this script, and it'll use it. But if you then go and load a new scene, you could now have a situation where there's two of these guys. And so the second one that comes in will just go into this code, right? So instance already exists, and it will destroy that object. And then that, again, enforces the singleton pattern, and just make sure that you don't have two of them. In the other case, right, so we return after that. So if it's existing, we destroy it, and we just stop all the code there. But if we continue, we go into instance equals this. So we're just defining that this mono behavior is our instance now. And then lastly, this is an optional line, but most of the time you'll want this. If you're doing singletons, is you're going to go don't destroy and load game object. And that just means when you load a new scene, this game object is not going to get destroyed. It's going to persist, and it's going to exist forever. There are situations where you might actually want it to get destroyed when a scene gets destroyed. But that's mainly if like the manager should only kind of exist in the life cycle of that scene, which can be possible. But I think for most times you're using a singleton like this, you'll probably want to do it like that. And that's pretty much it of the singleton. That's the simple little guy. I'm just going to delete that function because I don't need it anymore. And we're just going to delete the thing over there. But that's the singleton. So going on to this, the way you basically implement that in Unity is you have a little singleton script, and you have your singleton game object, and then you just drag your singleton little script on that game object, and then you sit there and it's done. So you just have to make sure that this game object is in every scene that you want it in. But besides that, that's pretty much all you have to do. And you have now a manager class that exists throughout the game. The other type of singleton, though, we can define here is a non-mono behavior, right? So there's advantages of having mono behaviors, and there's disadvantages of them. Obviously, by default, mono behaviors get destroyed each time scene loads, but you can kind of get around that with the don't destroy unload. But then the other thing is there is a little bit of an overhead of just having a game object in your scene and doing other stuff. So there's a way to get around that. It's just you don't make a mono behavior. But the main difference here is you could still make this a mono behavior. You could create a game object in this init call, which I'm going to explain in a second, and you could add your thing there. Because obviously the advantages of having a mono behavior is you do get to hook into some kind of the, update loops and on awakes and kind of stuff like that. And you have a little bit more control over the life cycle of the object. This one doesn't have a mono behavior, but it has the advantage of kind of being persistent by default. And with this function, and we define here, it'll get created at runtime, and you don't have to throw a game object anywhere in your scene. It just automatically gets created. So again, just to start, I'll just do line by line here. Same flow here with the instance, just named it the type that we have. It's static as a get, and it's got a private set. The fancy part on this one is this method here. So there's an attribute, which is what we call these little things in little square brackets. And we define a runtime initialize unload method. Now, if you hover over this, it says use attribute to get a callback when the runtime is starting up and loading the first scene. So by default, this just starts whenever you click play or whenever you would boot up a build of your game. This gets opened. There's even some small options that you can have here. If you go parentheses at the end and then you go runtime initialize, you can actually kind of set a little bit of ordering here in case you want to have something that happens before you have one manager and then you have another manager. So you can kind of do a little bit of control there, but there's not too many options there. You still have to kind of rely on the execution order if you need managers to kind of run after one another. But the nice thing again about this, it just runs automatically. You don't have to do anything in your scene. And as soon as the game loads, it'll call this function. And in this function, this is where we create our instance of our singleton. We don't have to do any if checks here or checks about if there's another instance around or anything like that, because this by itself only gets called once. Therefore, this won't happen more than one time. So you just can assume that it's only going to get one call. And that's where we assign instance to be equal to new runtime init singleton. And again, this is just a constructor that I define here. Because it's a C# class, we don't have to go instantiate or create game object or do other stuff like that. Again, if you did really want this to be a mono behavior, you could go, I don't know, game object geo equals new game object. You might want to put a name in here, some name. And then you can go instance equals geo dot add component, and then you would add the this if this was a mono behavior, and you could set, right? So you could do this. It's not going to like this right now because this isn't a mono behavior, but if you were going to make a mono behavior version of this, you could just write in this method this little line of code, and then you'd have the same effect. So I just wanted to show this version though, because this is a non-mono behavior, and that kind of just allows you little different options basically. Below, all that I have here is a private little function, private constructor, which is important to enforce the singleton design. You don't want to make other ways of making your singleton. So by making it a private constructor means that only this class can run this little constructor, which means that only in this method now that we've defined can we run our singleton. And I wrote this little function down here just again to show, right, in any other script, we can now go runtime init singleton dot instance dot my function, right? So any functions or any values that you define now on your singleton will now exist. And so this is just basically another good example of a singleton that exists throughout the game. You never have to know, you don't have to put anything in the game object. There's literally no setup in Unity that you have to do to make this run. It just exists, which is wonderful for making kind of a very basic setup, very quick, really probably good for game jams of your manager. So again, if you wanted to use this, all you'd have to do is take these little values for the class names, just replace all those, and then you do some initialization code here, put all your functions in there, you're done, you're good. Right? All right, so now we've talked about singletons. Now there's a couple of flaws that I want to just talk about singletons before kind of going on to the next step, which is what I use in my game in a bit more of a bigger project. So let me just find this manager. Should have had this up, but oh well. Base Manager Hub. I guess before actually going to the code, I should explain how these managers work. So, for example, the problem that you get into when you run into consistent just defining a singleton here, defining a singleton there, defining another singleton there, is you get into initialization order issues, which basically just means that I have a couple of managers here, right? So terminal manager, Morse decoder, permission manager, spawning manager, map generator manager. Then I also have a code assignment manager, I guess. And some of these actually require the other manager to have ran first, right? So very specifically, my map generator cannot work if these other ones are not created first. And that creates all sorts of issues where, you know, then you have to go in your singletons, you might have to find execution orders or do weird things to happen if they're purely just one-off kind of classes that are just kind of sitting around everywhere. And it'd be much better if you actually could define that order in a nice way and have them still kind of function as nice, easy, accessible managers. And then, so this is when you kind of get into containerization or hubbing of your managers. And so this is why I wrote this base manager class, which I'm going to get into why I wrote a base manager hub instead of just a manager hub in a little bit. But the core concept here is that I define a bunch of manager scripts, base manager. So anything that now is a manager script for me is a base manager, which I will go into a second. And all this has by default is just an initialization method, right? So you're calling it, and it defines a hub, which is the hub that's coming in, and a action for when your initialization is complete. And these manager hubs then in its awake gets all my managers in a get components call. So it's all the managers are going to be as a child of it. This does mean I have to, in my level manager, for example, I have to put all my managers in a row here, or in my other one, for example, game manager, I actually, instead, I have my hub here, and then I have each individual manager as its own little sub manager here. But this allows me to have them set up, and I can say I need to now have health manager initialized before stress manager. I just move that around, and there you go. It's already, now the initialization order is changed because I have now set it to be get components to children, which is, well, by default, get components and children will always return the order that it's enlisted. So I can define my initialization order that way. So I get all the managers, I add them to a key map, which probably isn't necessary, but basically there's a type dictionary and there's the manager, and I have this option so you can go and get the manager. I don't use this too much because I rely on the instance kind of referencing because I just find it easier to use, which I'll show kind of in a manager later on. But for that purpose, if you really wanted to, there's a lot of code, I think people that would probably enforce doing a get here, because then you have kind of like a centralized repository for all your managers. And if you want one, you have to go to here. But I've kind of settled on a little bit of a middle ground in that regards to just allow quicker access, because I don't want to have to do get each time and there's a lookup call. And so, I avoid all that. By the way, I'm going to try to copy every single one of these scripts that I've shown, at least like the base manager hub and the runtime singletons and stuff like that. I'm going to try to put those in a description of this video in some form or another. And so if you're watching this and you're like, wow, that's a lot of code, I have to like manually retype, don't worry about it. I will try to get that to you guys in a way that you can copy and reuse. So again, awake, we then go in Initialize Manager. And so this is a little bit of a funky method. But the core concept here is we're going to go through each of our managers. It'll take an index. It starts at 0, obviously, because it's going through an array. This is just a safety case, I guess, in case there's no managers. But it'll grab the manager at a specific index, and then it will go and initialize that manager. And so this is getting that call for initialization. And when it completes that initialization, it calls the same method here again, but just with an additional plus to the index. And so this way we call the method. It's asynchronous in the sense of I'm not waiting as a coroutine for this thing to finish off. It just, whenever it finishes, it will call this function, which will then restart here. It's kind of like a recursive asynchronous function. Not like truly async, but just in the sense that I don't have a defined end time. And it'll keep calling this until eventually the index is greater than the manager length, and then that's when we call on it complete. And if the particular hub needs to do something at the very end there, it calls that. But again, that in general, that just allows me to initialize all my managers in order. And if they need to do something that takes a little bit more time or has a little bit more initialization, kind of like my map generator does, where I spawn out all my level, that's not something I can do in just like one frame. So I need to have it wait a little bit, do some loading, do some configuration of different things. And then once it's finally done, it can then pass the torch to the next manager. And then that manager can initialize. And then the beauty of that is that when you're looking into each manager here, is that when you define this, you know that code display has fully initialized by the time that inventory manager is initialized, or is starting to initialize, right? And inventory has fully initialized by the time that store manager is starting to initialize. And it just creates a really clean way for me, at least, to define my managers and define the initialization. And the old way, the other singletons are great for when you just have one little manager that kind of exists in its own little world and you don't need to do anything else with. But when you start to have this many managers, and some of them have dependencies on other managers, then you really do need to start thinking about kind of their initialization order and all those other types of things. So in that regards, we have this defined like that. So before I go too far on, I just wanted to quickly loop back, because I said I was going to talk about how a specific manager initializes. And it's pretty simple. I just have this, right? I have this one method that every single base manager includes. In this case, I'm just talking over my item database manager, which handles all the information about my items. And in here, we define a static variable. This I could have called instance. I called DB because it's a database, and I just wanted to call it DB. But you could have called it instance or whatever. It just defines a static variable. It's not quite a singleton because this could technically get called different ways. It's not quite enforced, but through the manager hubs, it kind of is enforced. So, you know, it just gives me that easy loop. And so this is kind of what I was talking about, where the hub has a get, which could do that, but I just kind of often result to doing this because it's just quick and easy. I like going item database.db and then getting whatever I want. In here, this just doesn't really matter. This is just like whatever your manager needs to do, you do that. You set it up like that, and then on the bottom here, we go and call on complete. and that signals to the hub, right? This little action here, that signals to the hub that the code is now complete, and then the next manager should go. And that's all the initialization needs to do. I have 3 different layers of managers, so I'm just gonna let's do 3 little bubbles and talking about it here. So there's the persistent layer, there's the game layer, or it's games actually. I'll call it the save layer, and then there's the level layer. I don't want to write persistent, but maybe per will good. Now, in some games, you can maybe combine these two, depending on whether or not, like, if you have like 1 level or not. But I think for most games, you'll probably want to have 2 of these. So you'll end up having 3 levels, kind of 3 hubs, is what I would suggest. Persistent managers, I'm just going to start with persistent managers and explain kind of down the road. Persistent managers, as kind of the name implies, means that you have this manager that exists at the very, very, very start of the game. As soon as you like boot up and you see that splash screen, basically persistent managers exist. And they never die, they never get destroyed, they never get reloaded, they exist forever. And so an example of a persistent manager in my game, for example, I can just run over that and show you some examples. Persistent managers. So some examples. I have a time manager, thing that just tracks like whether or not you've paused the game, whether or not you've kind of started the game, or changed the time at all, or paused it, basically paused or started. There's an audio manager, tracks whether or not your audio levels are up and down. I think that eventually that guy will also probably handle kind of basic sounds that get played. My screen manager, my UI. There's a case to be made that you can probably divide this thing up into the game manager layer and then also the persistent layer. But for my sake, I just kind of decided that I wanted it to exist everywhere because it includes the main menu level, kind of the UI for that. But you could probably separate that out into 2 different screens if you wanted to, or 2 different managers. Difficulty manager. So this tracks not only kind of like what difficulty you're using, but also what are the settings of difficulty. Often a lot of the persistent managers you'll want are kind of storing data because, and I'm saying storing data that's static in the sense of like your characters, your items, not necessarily what items you have, but what items there exist in the game, right? So I have, for example, I have a piece of scrap metal. What is the data that defines what scrap metal is? That's what the item database holds. And a similar thing with store database. It's just holding all the data about my stores whenever I go to an upgrade table in this case. What is available in that store, but it's not necessarily that specific instance of a store, it's just what that store can have. There's object pools, defining data for level generation. Again, it's static data, not like the actual act of doing anything, it's just the information that every single manager that needs to maybe know about level generation is going to need to know about. And lastly, the save manager. Because if you're loading and saving a game, you need to be able to know that the loading and saving game manager always exists. He doesn't exist just in a game. So that's the persistent kind of managers. They, again, exist throughout your entire game and they never get destroyed. That's kind of the key point to them. Which means you do not want to really put any information in these guys that relates to a save game, like a particular save game or a particular level. These guys should kind of be static in that they don't really change at all. They gain all their information kind of at runtime, and then they're just a kind of repository for calls and end calls that happen whenever they happen. Now, the next manager is the save manager. And this, exists kind of throughout. Oh, sorry, wrong thing here. The save game, I call this game manager. I'm still not quite convinced on which name I should call this, but I call it save here, for example, because this exists throughout a save of your game. So whenever you load a game, as long as you've had that load in play, this manager is going to exist. This is nice because often this is kind of how the flow goes with games, right? You'll start in your main menu, you'll load a save, and then you'll kind of maybe run through different levels as you're going. And so it's really nice to have something that kind of defines that save and is kind of universal throughout that save. So in here, I just basically have defined a bunch of things that are not dependent on the level that I'm in. Basically, the prime example here, I think, is the inventory manager. Right, you'll load into a game, you'll have a specific inventory, you'll have some potions, you'll have some other random items, but that's unique to that save. So this manager only cares about what you have in your actual save game versus something else that might, in the future I'll show about, that manages kind of where, that manages only something specific to that level. So inventory, again, really good example. Health, I have a manager for that. I have a manager kind of to store what maps I've explored, but that's kind of like another example there. So again, these are managers that only exist throughout the lifetime of your save game. So as soon as you load another game, these managers all get destroyed and a new set of these managers get created. And it's important to know that life cycle because it's kind of where you can depend on them existing and how long they'll exist for. I think that's pretty important to remember. Lastly is the level managers. I kind of briefly showed this before, but just to kind of go again, talking about level managers. These things only exist throughout a specific level. So as soon as you go down to another level or change your levels or, I don't know, go back to a non-game level, these things would get destroyed. Let me just find it. All right. And again, so these things kind of specific to this level. The most, I think, quintessential one here, for me at least, is the map generator. So this manager handles the entire procedural generation of my map and also where items are saved. If you open a door, you know, that value gets saved. This thing only exists in a level, right? Because it is defined by that level. It only really exists in this level. Now, the interesting thing about level managers is that you can actually kind of vary them level by level, right? They're not necessarily consistent depending on your level. So when I go to my, like I have this little hub world or hub spot where I do a lot of my construction and I've got a pre-made level kind of that you start off in your tutorial area. I delete a lot of these managers because I don't need the map generator in that sense. I think I even probably delete spawning manager. But you can kind of set these things on a per level by level basis, and they don't always need to exist. But the concept is that in the levels that do exist, you kind of know what they do. And I've really liked this kind of division of these managers. Sometimes I realize that, like, hey, a level manager actually kind of needs to be a save manager. I've even decided sometimes that save managers need to be persistent, depending as we kind of come and go. But fortunately, that's actually really easy to change. You basically just change what they inherit from. So instead of the save manager inheriting from game manager, in my case, I just inherit it from persistent manager, and then I throw it under the persistent hub, and then you go. It's just pretty easy to flip those around. Anyways, that's probably my really long-winded explanation of all this. I really didn't want to go this long, probably, but you know, we'll hopefully kind of give some ideas to you if you're kind of creating some manager scripts and struggling to kind of organize them. I hope that kind of gives a little bit more information on that. And yeah, again, thanks for watching. It's kind of a long video, but that's what it is.